Hi, in this video lesson we deal with CreditMetrics. CreditMetrics was introduced in 1997, a very special year because most of the models related to credit risk appeared in 1997. It was introduced by JP Morgan, and it's a model that comes from the family of structural models of default. Actually, it derives from Merton's model, but differently from Merton's model and Moody's KMV. In CreditMetrics, the liability is not the quantity we use as a threshold. Rather, the threshold is defined in terms of ratings, credit ratings. These ratings can be internal or external. That is to say, they can be computed internally by the bank, or they can be acquired externally from a rating agency. We consider a company that has been assigned some credit rating class, say B, at the beginning of the period 0 capital T. Thanks to the transition matrix in CreditMetrics, we can not only study the probability of default of the company, but also migration risk. This is a nice novelty with respect to the other models we have seen so far. With P of j, for j from 0 to n, we indicate the probability that our company will be in rating class j at time capital T. We assume to have n plus 1 classes of risk, n classes plus the default class. We order the j's so that j equal to 0 means default, and j equal to n means that our company is in the best rating class, say AAA. With P of 0, we therefore indicate the probability of default of the company. The essential part of Merton's model remains valid. That is to say, we still assume that assets are following a geometric Brownian motion. But now we will not really split the assets into equity and debt. And from a certain point of view, this is even more consistent with the Modigliani-Miller theorem about the irrelevance of the financial structure. From Merton's model, we know that the log assets follow a normal distribution. Now, let's use the probabilities P of j to define a sequence of thresholds from d0 tilde to dn plus 1 tilde. I will omit the tilde in the rest of my talk. These thresholds are defined such that the probability that V capital T is between dj and dj plus 1 is exactly P of j. They are quantiles. D1 is clearly the default threshold. If T capital T is smaller than equal to D1, the company defaults in capital T. Thanks to the thresholds, we can identify in which risk or rating class our company will be in capital T. It is worth noticing that the migration probabilities are invariant under simultaneous strictly increasing transformation of both V capital T and the threshold D. We know that log V capital T follows a normal distribution with the mean and the variance we have already seen. We can create a new variable x capital T by standardizing log V capital T, that is by removing the mean and dividing by the standard deviation. Naturally, we can do the same for the thresholds. Notice that the standardized quantity xt is now following a normal distribution, but a very special one, a standard normal distribution, with mean 0 and variance 1. For what concerns the thresholds, we can now see them as quantiles of a standard normal. Okay, this is CreditMetrics in a slide. Again, we can use x capital T and the new thresholds to see in which rating class is our counterparty in capital T. Let's consider a simple example to better understand. We have a B-rated company and we have the following one-year transition matrix. Let x capital B be the value of the rescaled asset value according to CreditMetrics of our B-rated company at the end of the year. We know that X capital B follows a standard normal. How can we compute the default threshold D1? We simply apply the quantile function of a standard normal to the probability 5.2% that we can read in the transition matrix. We get minus 1.6258. If X capital B is smaller than this threshold, we have a default. We can use R or any other program to compute the quantiles, even the old-fashioned but reliable standard normal tables. Similarly, we can study the thresholds associated to the other migration probabilities for our company. We simply need to cumulate the right probabilities and to invert via the quantile function of the standard normal. You understand that one limitation of CreditMetrics is the actual possibility of having reliable ratings. This can be a problem for small and medium companies. If ratings are available, reliable thresholds are easier to define if we compare it with the other models we have seen. The CreditMetrics model can be extended to deal with a portfolio of counterparties, which is actually the most interesting case for us, but in order to perform this extension, we need to introduce copulas, and we will do that next week. In reality, in this week, on the course platform, you find another video lesson whose aim is really to introduce you to the basics of copulas. So for the moment, we just stop here with CreditMetrics, but we will be back very soon. So thank you for your attention and goodbye.